age of humans. We have changed this planet in extraordinary ways that no other animal ever has. Trash is accumulating in aquatic ecosystems like never before. Carbon dioxide emissions from our factories are increasing tenfold of what would naturally be produced. Ice caps are melting, accelerating at speeds faster than what would naturally occur. Construction of oil rigs and pipelines hasten energy-making processes that accelerate the increase in atmospheric temperatures. Natural gas is a billion-dollar industry. The EIA states that over 210 natural gas pipelines are spread out over 305,000 miles in the U.S. alone. That's a tremendous amount of land covered by these pipelines. We have an understanding of how natural gas affects the environment, but how does the construction of these pipelines affect the land around it? My research team and I sought to understand that very question. What impact does pipeline construction have on the surrounding ecosystems? We observed plants and how they were affected by pipeline construction. Plants are an important part of the ecosystem. They are the primary food providers, the base of the food chain. Changing the diversity and relative abundance of these species could greatly change the diversity and relative abundance of every species around them. Plants can even change the landscape, preventing erosion and in some cases even changing the placement of waterways. So, what do pipeline companies do when they construct pipelines? What occurs during construction that possibly affects the areas around them? Pipeline workers remove and preserve topsoil layers, then dig a trench deep enough to place the pipes. When the pipes are put in, soil previously dug up is used to fill the trench, and the topsoil is replaced back on top. But what kinds of effects can this have on plants? What measurements can we study to quantify this? My team and I measured the number of species and individuals in those specific species, as well as collected data analyzing the relative nitrogen abundance, an essential soil nutrient, of 3 soil samples at varying lengths away from a pipeline right-of-way. My team and I hypothesized that pipeline construction diminishes species richness and nitrogen concentrations close to the pipeline right-of-way. So what did our data show us? Ammonium, a compound containing nitrogen, was actually higher in concentration when closer to the pipeline right-of-way, which was the opposite of what we hypothesized. A hint of that same trend appeared for nitrate as well, though we will have to test more in order to understand how that compound is affected. Species richness was also affected in contradiction to our hypothesis. It turns out more plants, more species of different types of plants, are present closer to the right-of-way. Now what's this say about our hypothesis? We have to reject our null. What does this mean? It doesn't mean that it's wrong, no. Science is all about trial and error, finding evidence to both support and reject our hypotheses. Else we never move in a forward direction. We only move backwards.